Hello and welcome back to Precalculus. We are going to end our chapter 1 tonight, right? We're going to talk about modeling with functions, which is technically the word problems. Now, modeling in mathematics is the process where you take the um, situation, right, that you observe and you create mathematical functions, equations, which can further describe that phenomena you're observing. And we do that pretty much with everything. You observe motion and you say, okay, I'm covering the distance in some time, and this new concept that we are going to now invent is going to be called velocity or speed, which means how fast I'm going, right? So you might say, oh, but that's physics, or everything is a branch of mathematics, because mathematics is the one that gives the base for physics to exist, and then physics for chemistry and engineering, then chemistry for biology, and then right, you have engineering also springing from physics, and then engineering breaks into different branches and so on. But they all have one thing in constant, one thing the same, and that is they all have mathematics as the base. So you are going to find problems in business and economics, and we are going to deal with the environmental issues and problems, and we're going to deal with carbon dating, which is going to be archaeology. We're going to deal with I already said money, right? Economics and business, but money as well, right? And then a whole bunch of engineering stuff that we can work on as we discover, obviously, more functions and more applications. So today we're going to give some kind of introductory story about modeling, where we're going to say that you observe a concept in nature, and then you write mathematical sentence about it, which is equation, and then you can solve that and use that to further um, calculate, compute, predict, right, and whatever else. Now, uh, for instance, hourly wages are going to give us something like this. Um, some whatever job is 20 per hour, and 100 per day. Uh, so this is kind of some kind of salary. Now, what could this be? I don't know. Someone is working at a restaurant somewhere, so $100 per day is the money they make from the owner of the restaurant, and $20 per hour is coming from tips, let's say. It could be a mechanic having the same deal. It could be literally any other job could have this situation. So how much money do we actually make in a day? Well, clearly it depends on the number of hours you work. So if you go and you say, um, so money made in a single day is going to be $100 that you are getting, that's fixed, plus $20 times every hour you work. So this is how much you make. Now, when you carefully look at this, does this look like mx plus b, right? mx plus b. Yeah, right? So technically, the money you make is 20h plus 100. And you can graph that, right? When you start here and you say this is your 100, and then it goes like that. And clearly this would be your hours that you work. So if you work only 1 hour, you're going to end up at 120. If you work 2 hours, you're going to end up at 140. If you work 3 hours, you're going to be at 160. And you can see that the y-axis is spitting out the money as you are putting in more and more hours. So now if you have the model, right, you can ask yourself a question: how many hours do I have to work if I need to make more than 250, right? I need to make minimum of 250 because you have to do something. You have to fix your car. You have to whatever. So you are deciding to work that one day, and all of that money that you make that day is going to be, right? You have already paid other bills, the food is in a fridge for a week and all that stuff. So that one day is just going to be you paying off whatever, fixing the car. I don't care. So you can ask yourself, how many hours do I need to work to make more than 250? Now, more than 250, well, maybe you're just gonna make $5 more, maybe 10, maybe $100 more, right? You just want to have more than what you need to spend in that day, right? So, guys, the secret of being rich is ridiculously simple. Spend less than you earn. That's it. No matter what your income is, as long as you're spending less than you're making, there you go. You're done, right? Uh, so now you know that you want to make more than 250. So your 20h plus 100 needs to be more than 250. You don't want equal, right? You want more. You want more. So there you go. That's more. This side needs to be more than that side. And that's very simple with that inequality sign there. So now you just solve minus 100, minus 100, right? You know how to do algebra. The question is, do you know how to model the problem so you can ask this question? So 20h, so you want that equal sign there, whole class, 150, then divide both sides by 20, and age larger than 7.5. So I need to work 8 hours. Need to work 8 hours to make or earn, how about earn, more than 250. Now, when you work 8 hours, you are going to make 260, right? So 260 is going to be the salary for that day. So that means that when you spend 250, you'll have 10 bucks left over, right, for that day. Now, tomorrow, you might make another 260, you might make 200, you might go 300, whatever, but you will have these $10 left over right from the day before. So that's some very basic mathematical modeling. Another one of those is well, they have it in a book, text messages, which is very interesting. I mean, they will eventually upgrade that problem, but back in a day, right? Back in a day, many moons ago, right? People used to buy minutes to talk on a cell phone. So you would buy a package and they would count how many minutes you talk, and then those minutes would be you will be charged per minute of talk on a cell phone. And then later on, they said, oh, calling is free, but now texting is going to be what we charge per message. Now texting is free and included, but they charge for extra data. So 1 gigabyte of data is whatever, I don't know, $20. I really don't know. So when you look at this, right, there is always something that you pay per use, and then you also have your flat bill, right? So the cost to have a line is, I don't know, $20, and then you will be paying every 10 cents per text message. That's the same problem like the one we just solved, right? You just have different numbers because you have a fixed cost. Earlier it was $100 given by the owner, right, per day. Now it's the fixed cost would be the bill, right? And then plus the usage per use, right? Which means if it's, let's say, text messages, you multiply the price, let's say 10 cents, times the text message, right? Which is number of text messages you send. That's also something that you can do. Now that's going with data, the same deal, right? So you get, I don't know, 4 gigabytes included, and then if you go over that 4, they are charging. So you have the fixed one, and then you keep adding the other one. Now we're not really interested in, again, solving the same problem like the problem before. We are more interested in a problem that is comparing the two situations so you can figure out which plan is better. So now the one that is given with the text messages is really outdated, but you can actually see the important calculation, and then we can link that to something more important, right? Um, in um, in real life, that you would say, right? So one plan, so plan A. I ran out of ink. I need to get the other pen. Hold on. Where's my other pen? There we go. So plan A is 20 a month. Maybe I write 20. 20 per month. And 5 cents per text message. Plan B is $5 per month and 10 cents per text. Someone might say, okay, so which one is better? Well, how about you tell me which one is better? Because that's what this problem is all about. And is there a better and a worse plan? Let's talk about that. So we're going to write our functions, our cost, right? So cost A is 20 per month plus 0.05 per text message. X is the amount of text messages that you want to send. B, cost for the B plan, is 5 plus 0.10x, which is just 0.1x. Now someone's going to say, well, it's better if I pay less per month. Someone's going to say, well, hold on, that's $15, so that's 10 cents. So, right, that is it really worth it? On there are ways, right, to think about this. Now, you really cannot answer which plan is better by looking at the information that is in front of you, because one key piece of information is missing. Can anyone tell me what parameter I would need to tell you which plan is better. Because
X.
yes, exactly, the usage. Because I don't know which plan is better because I don't know how much you text. If you're not gonna send text messages, clearly B is better. I mean, we don't need to be nuclear physicists for that, right? If you're gonna send no text messages, well, obviously you're gonna get the plan B because plan B costs you $5 and plan A is $20. If you're gonna send zero text messages, then this part of the equation doesn't exist. So clearly B is better. But then you say, I don't know, I like to send 1,000 messages a month, 1,000 texts. Okay, which plan is better if you're sending 1,000 texts then? Well, you stick 1,000 for X, right? And you figure out. So if I'm sending 1,000 texts, right, then this is going to be 0.05 times 1,000. Now, the best way to deal with these decimals is always to use a fraction, obviously, because decimals are terrible. Times 1,000, see? So this 100 is going to kill off 2 zeros. So your bill is actually $70, right, with 1,000 messages. And on the bottom here, this 1 over 10 times $1,000, that knocks off 1 0. This one works to be 105. So now, if you're sending 1,000 messages, plan A is better, and it's $35 better. If you're going to send 0 messages, then plan B is $15 better. So there has to be this break-even point where one plan, right, where both plans perform the same, and then to the left and to the right of that break-even point, right, you're going to have one plan better or the other plan better. So it's very simple. You set two equations equal to each other, and you find that common x that both equations have at the same time. So when you subtract 5, you get 15. When you subtract 0.05 x, you get 0.05 x. And then when you then you obviously write this as a fraction because it's annoying to solve it as a decimal. That's going to be 5x over 100. And as you can see, you multiply by 100 and divide by 5. So x is equal to 15 times 100 divided by 5. So first cancel, then multiply, and it's very easy. So 300 texts is where it doesn't matter which plan you use. They're both going to cost the same amount of money. But as soon as you go over 300 messages in 1 month, plan A is better. And if you're going to use less than 300 text messages a month, then plan B is better. So it's a simple mathematics that tells us this, but we had to model to take this real life, right, experience situation and write the equations. What else do you have? Car rental works the same way. For this particular make and model, we have, $20 per day plus this much per mile. Great. So now I'm not going per text message, I'm going per mile. Okay, so let me just say x bigger than 300, plan A better, and then x less than 300, plan B better. Because at 300, both are the same amount of money. Now, as I said, car rental, you rent a U-Haul truck, there are a lot of these situations where you have the flat fee and then some fee per use. Do we have any huge life choices that we have to make when we start working? Oh, yeah. It's called health insurance. You are presented with options. Now, one option is no copay. One option is $10 copay. One next option is $15 copay. So you say, oh, which plan is better? Well, maybe if I just go the one that has a free, right, copay, so every time I see a doctor, I don't have to pay, anything out of pocket. I just walk in, walk out. Okay, sure, but your premium is larger because you're also paying into that health insurance, um, right, using your money. So that's going to be higher than the one that has a copay of 15. Now, is that going to be this? Yeah, it's exactly the same calculation because now I'm comparing the monthly premium and the payment per visit. So if my monthly premium for the health insurance is, let's say, $600 plus 10 per visit, where someone is paying $900 plus or $700 plus 0 per visit, right? Which plan is better? It's the same thing like cell phones, right? Set larger numbers, and you go and you say, well, again, what do you need to know? Well, how frequently do you go to the doctor, right? If you have a chronic disease of some kind, you go to the doctor all the time. If you don't have it, you might not go to the doctor once in like 2-3 years. So who's getting which plan, right? Because if you are going to go to a doctor, right, whatever amount of times, what do we have? We have the amount of visits times $10 copay plus the premium, where the other one is no copay, just the premium. So if I'm going to go to the doctor every day for 30 days in a month, well, let's go 20 days, right? Saturday, Sundays. Let's go 20 times. I don't think anyone goes to a doctor 20 times a week or a month, but let's just make a ridiculous situation. So if I go 20 times in a month to doctor, so the top plan, this is a P1 and this is a plan P2. So P1 is going to be $800, and the P2 has no copay, so it's $700. So if I am going 20 times in a month, obviously P2 plan is better. But let's say I go to the doctor twice a month. Well, twice a month is just gonna give me $20 there. So it's plan one in that case, right? If I go 2 times a week, then plan one is going to have me pay $620, and plan two is still $700. So there you go. Picking the car insurance, picking the car rental, picking up the medical insurance, picking up like all of these things that have something fixed plus per use. All of these equations are the same. It's just what is the concept that you are working with, and then making informed and correct choices, not just, oh, let me take this one because Joe is also using this one. Yeah, but Joe has a different set of circumstances that you have. Therefore, chances are that you and Joe are not going to be benefiting the same from the same health insurance. And as you can see right there in the calculation, it's pretty much on, right, how many times you're going to go because of the copay. But again, do we have to talk about that? No. We can just say, okay, cell phones, car rentals, right? But it's all the same mathematics in the background. Cool. Let's take a look what else we can figure out here. Uh, oh, so these particular problems are really really nice. So This is the real this is the real modeling now. So you want to try and figure out, well, what is your job? Let's first set up the parameters. You work for the airline company, and your job is to figure out prices, and you do the market research, and you try to figure out what is the right price. That's actually what marketing is for. It's not to create ads, and I mean, that's the part of marketing, but the real marketing is mathematics, where you are trying to figure out, and even calculations, where you're trying, you do the market research and see what products people actually want, so that your company can make those products. But also, figuring out the pricing. Clearly there's going to be a cost to make a product. If you are selling at a cost, then you break even, and you don't have money to do research and development, so other companies, right, surpass you, and you become obsolete and you fail. So companies must make profit, so that they can invest that profit, or part of that profit, into research and development, so they can come up with the next version of a cell phone, next version of a laptop, next version of a car, right, and so on. So the profit money gets reinvested in the improved new products, which is research and development, right? So you must have a profit when you are running a business. So marketing does that, right? Marketing allows you to figure out uh, what is the price, but then you also go and you check out, okay, what is that the market wants? And it doesn't have to, uh, you know, you can't go by common sense. You actually have to go and pull people and see what they prefer. One of my recent, you know, revelations was that Nintendo Switch, right, the handheld little video game thingy, was at one point, right, 300, or maybe still is, $350. And then Oculus Rift was selling a VR set for virtual reality at the same price. So my instant, right, for someone who's playing VR for a very long time, once I figured out that the little handheld thing, right, is also 350, my instant, thought, because again, I only considered myself, right, talk about self-centered and arrogant. I said, who would in a right mind waste $350 on a handheld, small screen uh, Nintendo Switch thing, where you can buy a VR set for the same money and be transported into completely different universe, not just for gaming, but also for um, watching 3D movies, and working in a 3D environment, and learning just to see apps about Google Earth, to try and experience Google Earth in VR. It's, you literally are walking down the streets in cities and towns that you will probably never visit, right? So when I compare these things, right, I can I don't see the value, because Nintendo Switch is little screen. I have the same thing on my phone, so what's the big deal? But then apparently there is a huge market of people who would pay gladly $350 to have, these video games on a little screen, and right, uh, instead of having this endless open world in a 3D virtual reality. So Nintendo is able to sell those, right? And they have the marketing. Another great example, even though I hate them from the bottom of my soul, is Apple. They're still able to sell their computers, which are so much worse and weaker than PCs in every aspect, that it's unbelievable. You lose 6 times the value, at least 6 times the value at the prices, compared to the power, compared to the equal PC. 6 times the value. That's insane. But we have a huge population that buys into their marketing and lies, and they're able to sustain the company. It's marketing again, right? So what is this problem about? Well, you are this marketing researcher, right? And you come up with a mathematical formula which says if I am increasing the price of a product, this is how many customers we are going to lose because the price is going up. So think of it as a football stadium and the ticket price is 20 bucks and 10,000 people are going to show up. If I increase the price to $21, we are going to lose 100 people. And if I increase the price for additional dollar to $22, we're going to lose additional 100 people, and so on. So there is a modeling there which says this is how many people we are losing because we are increasing in price. Um, Airplane tickets, which is, I believe, the one that we are going to take a look at. Yes, airplane tickets is the one that we're actually going to see. But then you can also go and say, about farms. You see, when you do the overcrowding with either trees or crops or something, they have a smaller yield. They're going to produce less apples or wheat or whatever you have on your farm. The same thing with cattle, right? If you have like endless chicken or turkey or cows or whatever, right? Or over farm with salmon, right? You have the farms for that as well. If you overcrowd, right, with animals, well, disease might develop and really spread uh, amongst a lot of animals because they're in close proximity to one another. The same thing with trees, right? They compete for sunlight, they compete for the minerals from the ground, and they're going to have, because there are a lot more trees than you should have, they're going to produce less apples. So the question is, at what point is adding trees? Um, at which point, when you start adding more trees, you are going to actually start losing on the overall amount of apples because that eventually has to happen. So technically, oversaturating the market and also, making way too many units, right, for the market that you can't sell. There are a lot of these things that you can make money with, right? This is the actual job, you computing and figuring these things out. So, as I said, as a part of marketing. So let's take a look at this problem. On a certain route, an airline carries 600 passengers. So, airline with 6,000 passengers per month, paying 200 per ticket. Very simple concept. You want to fly from, let's say, here to Florida, your ticket is 200 bucks. There you go, right? There is nothing to do. And 6,000 people are willing to pay at 200 bucks. And then it says the market survey indicates, this is where the marketing people come in, right? A market survey indicates that for each plus $1 in price, airline will lose 100 people. Lose 100 people. I don't mean lose 100 people from the plane or something. They are never going to come in and buy tickets, right? They lose 100 customers, right? So tickets are not purchased at all. They're not losing people that are already on the plane. So you have this problem, and you have 600 passengers, uh, 6,000 passengers per month on this. So you are thinking, okay, here we have Newark to Florida somewhere, whatever, 6,000 on that line. $200 is the ticket they're paying. Each ticket, if I increase by $1 in price, I will lose 100 people because they're not going to. All right, so what does that look like if I just make it like a table of values, right? So 6,000 people at $200 per ticket. Now, if I make this 201, I'm going to lose 100 passengers. And if I make this 202, I'm going to lose another 100 passengers. And then I make this 203, and then I lose another 100 passengers. So every time I tick here by one up, I tick here 100 down. So am I making money or am I losing money?
Well,
So,
every time you put the dollar amount up by one, you're making $6,000, right?
ah, that's correct. I am making $6,000, but I also lost 100 people, so it's not 6,000, it's 5,900, 5,800, 5,700, right? 5,600.
Oh
So
yeah.
I'm right. So every time, that's very good. That's very good observation. Very good. You are making, but you're still making more money than you're losing. But you know what? There is going to be that time, right? It may be it may be 300, or maybe 285, or maybe at 260. I don't know when, where you are actually going to start losing money because you are losing too many people to the price of a ticket, right? There has to be that point, and I just want to find it. But in order for me to find it, I have to create the mathematical equation so that I can compute this thing. Yeah, sure, you can sit here for, an hour and just put all of these combinations and then just compute them all by hand and figure it out. Excel can do that much faster, obviously, right? But we can also do mathematical equation. So now let's go with P is price, N is the number of people, passengers, customers, whatever you want to call it. And now let's go and figure out what is the mathematical equation that would uh, give us this. Now, price is going to be P minus 200. You see that? This creates the counter that will tell us um, how much more we are charging than what we initially charged. See, if you say, I want price to be $210, then you subtract 200, that means that the increase is 10, and then you will multiply that by the loss, which is a negative 100. So one more time, this over here is going to give you, it's like a counter, how many groups of 100 people we are going to lose. Because every time the difference is 1, 2, 3, 4, 5, 6, right? You lose 100 people. So you say, what if I set P to be $250? Well, then this number is 50, and then times this, you lost 5,000 people. I don't think you're going to do too well, right? If you lose 5,000 out of 6,000 passengers. So what this calculates here is, again, the price minus the 200 base price is going to give that difference. The difference is multiplied into negative 100 because per dollar of difference, you lose 100 people. And that's taken away from 6,000, which gives you the new amount of people that are on the plane. So kind of equation is calculated from the back right forward. So let's write this equation one more time and understand which way we get this equation. So I start by first setting up P minus 200 because that's going to give me a counter which will tell me how many groups of 100 people I'm going to lose. So if I have, as I said before, if I have 210 for a ticket, then 210 minus 200 gives me 10. 10 times 100 is 1,000 people lost. Now that's all taken away from 6,000 which were originally on the plane. So this is the number of people that will actually be flying at the price P. So this equation here, the whole equation, is going to be number of people flying at price P, not at 200. We know that if you have 200, you will have 6,000 people flying. Since your price is larger than 200, which is the price P, and we leave that open as a variable, right? Because we want to play with that number and see what is the actual number that is there. So now I can go in and I can calculate, right? Simplify. So 6,000 minus 100p plus 20,000. When you distribute negative 100 to both, right? That's what you get. And then n is equal to 26,000 minus 100p. Okay, I have my equation. This is the same concept, it's just it looks different, right? It's the same equation, it will give you the same numbers. Okay, so now what's the revenue? How much am I collecting money, right? So the revenue, right, is the amount of money that you make by selling all of your products or services or whatever, right? It's not a profit, it's what you do. So revenue is the money made from sales. I don't care whether the sales are services or products, right? But that's what all the money you get in. And revenue is going to be the price times the number of units. So price times the units or services. So how many of those you sold, right? If your job is to sell donuts, then the price of a donut, $1, let's say, and then you sell $1,000, so you make $1,000. Is that $1,000 for the pocket? No. You have to subtract the cost of making the donuts, all of the ingredients you used, and electricity and everything else. So it's much more to running a business than, just selling $1,000 donuts. So now my revenue is going to be the price times the number of people flying, because that's the number of units that are sold, number of tickets, right? One person, one ticket. So I'm going to have P times 26,000 minus 100p. And the revenue is 26,000 minus 100p squared. This is, as you can see over here, there is a negative and p squared. So when you have x squared, your parabola looks like this, the U shape. We've seen that in class, right? When we did transformation of functions, when you put the negative x squared, it looks like this. So this means that if you are to graph this, you are going to get a graph that looks like this. Now, much more on this, obviously, in graphing in chapter 2, but right now, even if you use the calculator, right, revenue is the money, R. And P is the price. So it seems that there is the maximum value, which is called optimizing. Whatever that peak is the price that you should set for the maximum amount of money to be made for the company in that case. Now, how do you find that value? Well, that's what the chapter 2 is all about. There are ways to get all of this stuff in your calculator, obviously, and so on. There are many ways. There is a formula that you learn in calculus, sorry, calculus, in chapter 2 in pre-calculus. There is a formula that will easily compute that value. Oh, this is there's a p over here, guys. I just noticed. Oops. Because this p multiplies that and multiplies that, but p times p is p squared for the last term. There was a p that I missed right there. So, I mean, if you want to know the formula for the max, it's going to be p equals negative b, so negative 26,000 divided by 2 times 100. And that's going to be the price. So that's going to knock off 2 zeros, 130, and there's going to be a negative number because there was a negative 100 there, so then negative cancels. So apparently we have to subtract the money because it seems that it's 130 bucks to give you maximum profit, because they would bring more people in, right? They will bring more people in, and you actually have to make now the argument that in order for you to maximize the revenue for the company, you are not supposed to increase the ticket price. You are supposed to decrease it to 130, and then the influx of new people would be so much that you will actually peak out. Because if this number over here is $0 and this is your 130 for the max, then your your $200 is going to be somewhere in there, which is clearly less money than maximum money, right? So these are the things that you have to eventually, right, deal with when you start working, because you want to. I mean, you need to, right, compute these things for the company if that's your job. Let's take so a lot of applications again about this, as I said, uh, but technically market research, and I did talk about farmers and the yield, which actually leads me to another problem with the farmer, which is very, 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 very interesting, and that is enclosing a rectangular area with certain amount of fence. So farmer has 2,000 yard of fence. He wants to enclose a rectangular area of maximum size. I don't care why. For cows or for sheep or for orchard, I don't care why. For a project. I don't care what the project is. But I understand the question. He already has 2,000 yards of fencing sitting somewhere on a pile. Great. So if I am on the, so if I already have that, then I just want to use all of that. I don't want to go buy more, right? I just want to use what I have and enclose the maximum area, and that's a rectangular area, so it's x, x, y, y, right? So how's this done? Well, you can do the trial and error, obviously, but it should be clear that 2x plus 2y is equal to 2,000, because the fence is a perimeter fence. It goes on a perimeter of your rectangular area. That's it. You use up all of your fence, right, to get this area. So now you have that equation, and you also know that your x times y, which is area, you want that to be a maximum number, right? Now the problem is that your equation for maximum has two variables. Well, luckily, you can use this equation on top to reduce the number of variables. So let's do that. You divide this puppy by 2, and you get x plus y equals 1000. And from there, y equals 1000 minus x. And then you just plug in. You kill the y. You see? X times 1000 minus x is equal to some maximum area. You can also call that f of x if you want to. So your f of x, which is the area, is equal to 1000x minus x squared. You now go, wait a minute, that's the same as the equation we had before. Yeah, just different numbers, but it's still, right? If you compare it, what was it? 100,000 minus, okay. So 1000x minus x squared. Like, just a little bit different numbers. It's the same equation. It's going to give me the same picture. It's going to be the same idea, right? We're not computing these. We're just setting these things up. So you can also say area of x if you want to, like a function is area function, is 1000x minus x squared. That is going to graph this way, where this is your x and this is your area. Clearly, there is the maximum area for whatever x produced that value. Now, we need calculus to make this calculation better and more like less painful. But you can still use that formula I mentioned before, where you go negative b over 2a to figure out the value for x. So the negative b over 2a, we are going to cover this formula in chapter 2. Some of you probably already covered this formula in your it's formula for the vertex of the parabola. Vertex is this, or if you look at this way, that minimum or a maximum. That's the formula for x coordinate of it. I know that some of you covered it. It depends what you have, previous education. So if you have this formula of negative b over a, you can actually calculate your x of negative b, that's negative 1000 divided by 2 times negative 1. And the thing turns out to be 500 yards. So you already have x, you go here, you calculate that the y is also 500, and there you go. You have 500 by 500. Oh, that's a square. Yeah, square is a special rectangle. It's still a rectangle. It has 2 sets of parallel sides. It has 4 90-degree angles. So it's a rectangle. But it's a special rectangle because all sides are the same. So just like the circle is a special ellipse. You will see that when you do the equations in your Precalc in the second part of the course, when we do chapter 9, we'll see that the circle is a special case of ellipse. Ellipse is just a squished circle. Their equations are the same if you make the 2 different radii that you get for ellipse. If you make them the same, you will get a circle. So yeah, the square is a rectangle of maximum area. Anytime if you want to maximize an area of the rectangle, you will get the square every time. That's what it is, right? But then you can improve these problems because, right, the situation over here is just this rectangle, right? Now you can lose one of the sides. You can right? So you can have it adjacent to the river. Here's the river. Here is the rectangular enclosure, and now you have 1x and 2y's. That changes your perimeter formula, because now you have single x plus 2y equals 2000 for the fence, because you don't use the fence in the back. There is a river there. So that's, or you can maybe have them split like this, in which case you have an x and you have an x, and then you have 4y's in this situation. So now perimeter is 2x plus 4y equals 2000, because you want bins, right? You want to separate. Maybe you have 3 different types of animals or 3 different types of apples or whatever, but you just want to fence off the middle, right? So you have three regions. Right? The geometry of this, it doesn't really matter. If you go around and just collect enough x's and y's to, right, wherever you have a black line, that's where the fence goes. So it has to be counted, right? I have three black lines here, and those 3 black lines are all fences, and that's why I have 3 of them here, x plus y, right, for the perimeter. In the second case, right there, I have 6 lines, 6 black lines. Top and bottom are both x's all the way through, and then you have 4 vertical y's. So x and y, top and bottom x, and here are the 4 y's. So a lot of this stuff is like these farmer problems. They are very, very popular, and you're going to solve, guys, the entire section here, the entire 1.10 that we are doing now. You are going to repeat every single one of these problems in your Calc 1 class, except you are going to use derivatives to quickly compute x and y, right? Now, we don't know derivatives yet, so we can't really go there unless we use the vertex formula. We can bypass it, or graphing utility, right? We can get the maximum that way as well. But you will be able to compute all of these things without the graph and the calculator when you hit Calc 1. As I said, the same problems will be there. So there are a ton of these word problems that you can practice. I went through, I believe, 60-70% of what's presented. They have a lot of cool exercises. They say, oh, piece of wire is 8 inches long. The wire is cut into 2 pieces, and then each piece bent into a square. Express the sum of the areas of the squares as a function of the length of a cut. Whoa, that's awesome, right? It's more like a puzzle, right? You have a piece of a wire, and you make, which is 0 to 8 inches. Yeah, 8 inches. And you make a cut somewhere, which is x. Then you take the small piece of wire and you bend it into a small square. And you take a large piece of the wire and you bend it into a bigger square. It says, express the sum of the areas of these squares. So area is area 1 plus area 2. This being area 1 and this being area 2. Smaller and larger square. Well, where do you begin? Well, you have one piece of the wire. What's the other piece of the wire? Well, if you're cutting off x here, then the rest better be 8 minus x, because that's how you write the leftover, right? If you have 10 apples and I eat 4, the leftover is 6. So that's, or actually let's use 8 apples. So if I have 8 apples and then I eat 3 apples, then 5 are left over, because 8 minus 3 is 5. So if I cut out X amount, the leftover is 8 minus whatever I cut out. Now this X needs to be bent so it makes 4 sides, so that clearly each side is X over 4, because I have to take this and bend it in 4 ways. And the same thing here. Whatever the length of the piece of wire is, I have to cut it into 4 equal pieces. And now I know that the area here is X over 4 squared, because you take one side and square it, right? Area for the square is A squared. And on the other one is area 2 is 8 minus X over 4 squared. And now you're supposed to combine these and add them, and you're done. So A1 is X squared over 16, and A2 is, you have to square the top. That's 64 minus 16X plus X squared over 16. And now if I want to add them, we're just going to write this properly, write the highest exponent first and then the rest. They already have a common denominator. Woohoo! This is a 2x squared minus 16x plus 64. And then your area in terms of the cut is, you can factor out 2 on top, and then you can cancel. So that becomes 1 over 8. And that's it, right? 1 over 8 times x squared minus 8, x plus 32. Now, you can, distributing this would not make whatever. Whatever, yeah. And yeah, that's it. It's really cool. So you say, oh, I'm going to cut off 2 inches, right? And then 6 inches would be the rest of the wire. Well, then you plug in 2 right there and right there, and you have the area of both squares together immediately. This is more of a puzzle and like fun. This is problem number 18. Did I put 18? No, I didn't. It's 18 from. So you have about 70 exercises to enjoy. 64, 65, they're really cool. Here's the problem 33 is the one for shipping. Yeah. Containers and so on. So there are a lot of cool problems that you guys can practice here. Um, it's very important when you're solving these problems to, what I say, claim them, right? Embed yourself into the problem and try to make it um, important and try to make it meaningful, and then you might have more stamina and desire to actually solve it. But this is what money making looks like. None of the stuff we did so far makes you money directly as this particular section does. So as much as those 3 sections, 1, 7, 1, 1, 6, 1, 7, and 1, 8, we're setting up functions for all of your courses to come, right? It still doesn't make money, where this section, as you can see, clearly makes money. So hopefully you will dig deep into this and bring questions. Any questions right now?
What was the 26,000 from?
26,000. It's 20,000 plus. There you go. So when I distribute this 100, I get these two
Okay.
terms, and then I add 2,000 and 6,000 to get 26,000.
All right.
Right?
Got it.
Good. Anything else? All right. And I'll see you next class. Bye.
Thursday.
1 second just to